Hi, Penn State Security Series Group. Glad everybody could make it online as well. I'm Jeff Minnelli, and I was asked to do a security series talk. So I have chosen threat modeling. When I first came up with this talk, how do we roll out services in DLT, and what have I done initially to secure all the different areas between networking, application development, storage, etc. All the moving pieces that you need to put together to create a service. So I was writing it all down, and I realized that my methods tied together directly with this thing called threat modeling. There's a lot of places that talk about Microsoft, SAN, OWASP, which is the Web Online Security Group. But I wanted to share how I did it, not following their model. I'm a very question-oriented person in my brain. When I was young, my uncle, grandfather, they always asked me why I asked so many questions. So I guess it worked out pretty well for me. So that's where this talk came from. So who am I? I think pretty much everybody I see online and in this room basically knows me, minus one or two people. So this will be really short. I was hoping to get 5 or 6 minutes out of this slide. I've been working for Penn State since 1994. I was part-time Unix admin. My mentor and the person that hired me originally was Jim Duncan. He was extremely security-oriented, security-conscious, and everything we did was always focused around security as we rolled out services or did any kind of work on the computer. So that's just stayed with me ever since those days. I've done everything from networking to desktop to support to storage to you name it. If it's in the Unix world, computing world, I've done it. Anything older than that, like VMS or CMS 6, 2.0, whatever, I haven't done that. I currently work in ITS, part of the DLT group. I'm a DevOps engineer. That basically means I work between the application programmers and the infrastructure folks. So a lot of my focus has been directly on those areas. So the thing we're going to talk about today is threat modeling, but I'm going to base it around Scholar's theory and how we came to secure that application. Threat modeling, I'm going to read these 3 sentences off real quick. SAN says it's a process to ensure application security. Microsoft says it systematically identifies and rates the threats that are most likely to affect your system. OWASP states an essential process for secure web application development. I take it a step further and say it's a process to secure anything you have in the computing world. If you want to look at it from the programming layer, the development layer, then it is exactly these definitions. If you want to look at it as a network administrator, you can apply those the exact same definitions in modeling to secure your network, secure your storage, secure your OSs. It's a great method. So overall, basically, threat modeling is a way to outline, illustrate, depict, however you want to choose your verb, to identify the system's attack surfaces, whether it's at the network layer or the application layer. I'm going to keep saying those words over and over and over because every one of those parts is key to securing your application and keeping your job. The 5 W's, if it wasn't obvious in the title, it's the who, what, when, where's, why's, how's. All the journalists know them as the 5 W's. Most people in grade school pick that up. So those are the questions that are always, they're the words that start my questions in almost everything I think about. Just to give you a little more context about me in thinking, this is going extremely quickly. I'm always asking questions. I'm always thinking about critical thought. Socrates comes to mind with me all the time because it's always, the Socratic Method is a dialogue between asking 2 parties to answer. One person will ask a question, the other will answer. You keep going until you can dig down all the way into where you want to, until you finally get to the root of the cause where you want to be. Always search for your answers. Google's a big thing for me. I live in the world of Google. There's a lot of smart people out there, and that's the best indexing tool on the planet for your questions and answers. Research and study till your heart's content and you're tired. You're always in school. You're always learning in this job. So the general process for threat modeling is you have to gather information about the entire stack from the ground up. So you start your networking, your OS, what OS dependencies you have, your application stack, what dependencies each of those pieces have. And so you just keep going through and identifying all the parts. One of the most critical parts is obviously the customers and the assets. You have to identify the assets to know what you're protecting. You have to identify the customers to know how to protect them and why you're protecting them. And as you go through here, you'll see I just keep throwing who, why, how, what, when. And you just keep breaking it down into pieces, smaller and smaller pieces, until you can isolate the part that you want to secure. And then it's a sum of the whole threat modeling, essentially. And then you'll draw it out. Drawing is a fantastic venue for actually seeing where all the pieces come together and how they come together. I'll show you that in half a second here. After you do that, you want to identify all the areas that may or may not cause the problems. Big points in web applications are certainly data entry and exit points. If somebody can inject words, strings, whatever into your applications, you want to make sure you take care of that stuff, because that's where most of your problems lie in web applications. You also want to look at the different data restriction levels of the assets you want to protect. You have to make sure you understand if the public is allowed to only see X data. They only see X data. They don't get to see Y. If you're authenticated, you get to see Y, but not Z, et cetera, et cetera. Then you define the threats. That's a little bit harder to do because there are so many threats out there. And that's why you always have to search and ask questions and utilize your coworkers, your peers, security office, et cetera, because there are experts in all the different fields. You just have to tie them together to get what you want. From there, you have to look at the different angles of attack and how they might attack those specific threats and exploits and get an understanding of what you need to do to block those. For instance, SQL injections. The easiest method is to sanitize and validate your input before you stick it anywhere, and then all of a sudden SQL injections no longer will occur. So that part, it requires, you have to do a lot of mitigation of these issues and identifying them. And then all of a sudden, you have this great working model, which I should say is a continuous model. You always want to be doing this every time something gets upgraded, whether it's the OS or the application or part of the stack. You want to review everything you've looked at already and look at anything new that might have occurred. For instance, we use Ruby on Rails. Ruby just had a security vulnerability. We're in the process of upgrading the Ruby code just to make sure that the holes are covered. And so that's a continuous thing. And so then I forgot where I was. Anyhow. All right. So the data flow diagrams. This is what I find to be one of the most useful parts of threat modeling as it's described online and in classes and offerings. It's a way to visually represent your model. This is an example I stole from OAuth. We're going to actually use ScholarSphere as an example here in a few minutes interactively. But you can see they define users, they define librarians. You can see that so this is about a college application website. And you can see where the data requests and responses are. This is the kind of level and view you want of your application so you can identify your threats and mitigate all issues. There's specific notation that you can do if you want to follow the exact data flow diagram modeling infrastructure. I don't. I just draw it out in boxes and lines. That's all you need to do. Oops. Excuse me. Sorry about that. There we go. So diving into those W's, a lot of the things you want to think about are what you're protecting asset-wise, who you're protecting it for, the technology stacks. With Ruby and Rails, you have to worry about Apache, Mod Passenger, anything that is part of the stack you have to worry about. Best practices. There are best practices guides out there for networking, your best practices guides out there for Rails development, best practices guides for Perl development, et cetera, et cetera, et cetera. Go look them up, read them, understand them, implement them. You want to look at your network paths. Who can see what on your networks? Who can't see what on your networks? Where does the data come in from the customer all the way to the storage? You want to look at all those steps and points. You want to input all your you want to validate and sanitize all your inputs for no matter what you're looking at. Authentication, authorization. You want to look at your processes for how you do that. Compliance and regulation. If you're housing data, you want to make sure that you're compliant and following the rules. That's a great spot where security and risk and the risk office can come in. We have DLT used them numerous times. Talk about HIPAA, FERPA, pick an acronym that might put you in jail for housing the wrong data. The other thing you want to worry about is what's the impact if somebody were to hack into your systems and destroy your data? What's the business impact? Because we're here for value. So we have to make sure that we handle that in a graceful and quick manner if we have to. And there's 10,000 other questions that you may or may not have. Hopefully you have. And questions come with time. The more you do it, the more you'll see it. I'm forcing people in the primary audience here to do a little interaction with me. So the people online, please bear with me as I'm doing this, because I might do a little bit of whiteboarding. So for ScholarSphere specifically, I started with a simple drawing. As you can see in the top of the presentation online, hopefully you can read it. I drew it by hand and scanned it in, because I am terrible with anything that requires drawing other than by hand, and that I'm not too good at either. So essentially the first drawing is you have your client, in our case a web browser. You have to talk to an application. Okay, that's the first part of the drawing. That's easy, right? The application, you can draw out the application stack. We use a thing called Hydra. It's a community that we're part of, we're developers in. And it's a stack of modular pieces that we've put together over time. It includes the Rails world, the Ruby on Rails world, Fedora, which is a data repository, Blacklight, search engine, nice web interface for on top of Solar. And Solar is a software package that does indexing of any data you stuff in it. And there's a tool, Solarizer, that sits on top of that to work between Fedora and Solar. And I just want to give you an overview of that, because those are all moving pieces that we have to look at in our stack, as well as the rest of the physical layout. And then from there, I expanded it down to the networking view, where I wanted to see the data paths where all my networking might travel, all the data from the client to the end. So the way ScholarSphere is laid out, we have a load balance in front of multiple applications. So for DR and business continuity purposes. That sits in VMware. VMware uses a storage network. The application itself uses a NAS, online storage, SIFs, NFS, to store the data for our application. I marked out a couple of them because in this, we don't have to really worry about it because I have an infrastructure team that I work with, and they're the ones that worry about those pieces. The VMware is making sure that the threats for VMware are mitigated. The threats for the storage, both on IP and SAN, are mitigated. And likewise with the load balancer. Where I'm really worried about is the data from the client to our application. And at the top of the screen, you can see that again. I would like to show everybody the next screen, and hopefully the people in this room don't cheat, as I guess I won't be using the whiteboard anymore. So I went a step further and showed all the physical paths between the applications and all the parts that we have to worry about identifying. So you've got the client. The client's just a web browser, IE or Firefox, take your pick, and it connects to a load balanced web application, which is then tied to two applications, I should have numbered them, app and app. Just pretend it's app 1 and app 2. Both of those share a database, an SQL database for state information to keep them in sync. From there, that Solarizer you saw in the stack, the last page, talks to Fedora and Solr. So each application has to talk to Fedora and Solr so it can see the data and the indexed information that we can put on the web so people can search for the information inside of ScholarShare. The SQL, the Fedora, and the Solr all reside on a NAS storage box. So I had those lines there. I didn't show the sandbox storage for VMware for the applications in the OS layer because, like I said earlier, it's not where I was actually looking for issues. So as you look, so what are some of the potential areas and issues for problems? And I'm sure people can name a lot more than just the few that are here. On the browser side, there's caching, cookie-based and password. That's not a good thing. Not much you can do on the client side. So we move from there, especially if it's somebody's home machine. We move from there, the connection between the client and the load balancer. In this case, it's HTTPS. Anything over HTTP, we automatically redirect to HTTPS before any authentication or data is transferred. It's just a quick redirect to get you on the right line. So that's encrypted. There's all kinds of attacks that can happen on the SSL and TLS side of things. A couple of them are hijackings, man in the middle, beast mode. I know Tim likes beast mode in the back there. And between the load balance and the applications is also encrypted links using certificates. Same thing, SSL, TLS. So you could actually have attacks at that layer too. If you're on near our local network or could see into those paths. That's another area. The application, Fedora, SQL, they're all vulnerable to injection attacks if you're not sanitizing your input, validating your input before you pass it on to those specific tools in the back end. Like I stated a few minutes ago, if you don't sanitize your input, you could have SQL injections and then you lose all your data in the SQL database. You could lose your data from Fedora as well because of the injections. Or they'll just dirty your data and then you no longer have anything that's useful or viable for your customers. Fedora, specifically Solr, the way Solr was written by Google, or I'm sorry, Apache wrote Lucene and Solr, is that it's a wide open protocol. Transfer paths are unencrypted. There's no authentication or authorization of any sort in Solr, and they designed it that way specifically because they wanted an open source package that people could just use, get it up and running. So we do all kinds of controls on our side. We do firewall blocking, we do port blocking, we control the network paths, and that's about all you can do for Solr. Put it on the same box and it's local over sockets. So that was a tough one to really reconcile with everybody. Because unencrypted data makes a lot of folks unhappy. I can see the eyes in here going already. Fedora has some auth-in and auth-z mechanisms in place. We're starting to play with them a little bit more because Fedora is a very, difficult tool. It's written in Java. Not that Java is difficult, just unwieldy. So the unencrypted links suffer from network sniffing, man-in-the-middle attacks as well. You can get some data corruption there if you're not careful watching what comes in and out of those systems as well. So I have a couple other bullet points up there. In front of the application, you could have cross-site scripting, cross-site request forgeries. I said that backwards. Cross-site request forgeries. And I'm not sure if everybody's familiar with those two kinds of attacks. I'm not very familiar with them. I know what they are. I know what they do. But I learn about all these attacks as I go to OWASP. And OWASP has this great top 10 list for protecting your websites and data applications. And those are two, along with SQL injections, that are three of the, I think, top 6 exploits you can have. And all of them are protected by using encryption, by sanitizing and validating your inputs. Just by doing that with your developers, you've protected yourself from at least 3 or 4 different kinds of attacks you can have. So sanitizing and validating your input it's critical. And you have to sell that to your developers around. Make them aware, make them understand. Not that I'm attacking developers. Jen asked me to have polls. I don't have any poll questions, but the one question I'm going to pose to everybody right now is who's the worst for your network? Programmer slash developers, hackers, or admins? Anybody? Users? No. Admins? Anybody for hackers? I say all three, because everybody has weaknesses, and you all have to work together to protect yourself from them. So there was my poll question, Jen. I hope I got bonus points for that. Excellent. Great. So are there any kind of questions or interaction? I wanted to do this more interactively on a whiteboard so I could get some participation, get some thought going, get people's brains and blood moving. I guess I should apologize for how late in the day on a Friday at the end of semester this is. We'll figure out who did that and blame them. But are there any questions from online or in here about any of these stages or what kind of tools I use, anything? Cool. Yes. Oh, I'm sorry. Hold on. We have the gizmo. Yeah, you're online now.
Do you run vulnerability scanning software at all?
Yes.
Your application?
Yeah, we do. Yeah. So that's a couple bullet points. That's a couple pages away, but yes. No. That's fine. It's just bullet points, right? So yes, we use vulnerability scanning. SOS offers a great service. It uses Nessus, Xenix, right? And Acudix. I don't know. They run them for us, and I can show you this towards the end of the presentation. I can pull up one of the scans. So they scan everything. You can tell them vulnerability scans for your whole OS down, and it'll scan all that, and you'll get a report. And in the report, it'll rate them low, medium, high, and it'll give you a CVE, common vulnerability exploit. I don't even remember what that is. It's a database of exploits and vulnerabilities. You can go there, see the explanations for it. The problem with that is it doesn't always have exactly the solutions. You have to do a little bit of work to figure out how to mitigate those vulnerabilities or exploits. And the other ones do the exact same thing. They just scan your application. They'll scan any form, and they'll try every input in the form. They will try 10,000 different kinds of attacks. If you don't turn your email off if you want to scan your web forms, because you will get 10, 20,000 emails, and that's painful. But each input in the form will be checked for SQL injections, overflows, cookie tampering. There's tons of checks that they do, and you'll get back another PDF with the same low, medium, and high hit risks, and then it'll show you the CVE and what you may or may not be able to do about it. In most cases, solutions are really easy to help mitigate the issue. And then once you know how to do it, you can take those. And we've rolled out other services. Before we do these scans, we apply all those fixes to the new systems, the new applications. So when the scan is run, we don't have to worry about getting it again. And if something's changed, we'll find it. So yeah, we do a lot of that scanning. Think courtesy of SOS. If you go to their website, there's links for those tools. Okay. So another tool I use, since I don't have a question, is it's called Qualsys SLL. It's a web SSL. It's a website, and I've got an example online that I'd like to show if we get to that point. If you go to their website, it's a form. It says, please enter your application's address. You put in HTTPS, Scholarship, PSU, and then there's a little checkbox that says, hide this output from the rest of the world. Because if you don't, it'll show it up that they're scanning your website. And even though anybody can scan your website, it's nice not to show the whole world that you're scanning it for vulnerabilities. And it'll go through all the SSL and TLS attacks. There's a lot of things in there I don't understand. We've scored an A, but there's parts where we haven't mitigated. There's SSL handshakes you have to worry about, and retransmissions, and all kinds high-level stuff that I don't understand, I speak to experts about, which is Google and SOS, if I have questions that I can't resolve myself, or coworkers. Um, so that's an awesome tool for helping an SSL-protected site. I guess that's it. And here's my joke for the day. It's my pie chart. Thank you. I feel better for putting that in. Too bad it's lemon meringue and not pumpkin. Threat modeling, for those that want to go deeper and understand it more, I just really discovered it not too long ago. Like I said, when I first did this, I applied my methodologies. I wrote them down and I realized they mapped out pretty well to threat modeling themselves. Threat modelers out there have much more extreme and useful ways of identifying their threats. For example, there's this thing called STRIDE. It's just a classification chart to show the exploit types that you can identify. Spoofing, identity tampering, repudiation, information disclosure, denial of service, elevation of privileges. They're the main types of issues you can have in your threats. Repudiation, logs, auditing. If you have that, then people can't deny they've done or not done something. So that's what that one is, because I can never remember that word. I'm terrible with my English. Another important use, I shouldn't say important, it's another part of threat modeling that I don't use myself, but you can. It's how do you quantify your risks? And it looks at damage potential. Is it reproducible? Is it exploitable? How many users does it affect? Is it discoverable by the world on scanning? Essentially, you rate this. It's you essentially rate each of those, and you do some multiplication and math. And the higher the score, the more important it is for you to fix that issue. It's a higher priority to fix. You can read more about that. So just kind of wrapping up. Wrapping up was the wrong term. But some of the things that I think are important in this are know your threats. Obviously, you can't know all your threats. This is where studying and learning continually comes into play. Secure your networks, your hosts, your applications, your dependencies. Incorporate security into development practices. Get your developers to security courses. Get your infrastructure teams, your operations teams, your networking people to security courses, training, etc. You know, the more you know, the less likely you are to be hit. Well, I shouldn't say that. The more you know, the more likely you are to stop some issues. Focus on principles, patterns, best practices. They're out there for a reason. Smart people wrote them, and they really make your lives a lot easier if you follow a lot of them. Again, continuously monitor your whole life, the whole life cycle of your application or your network or your storage. If you don't, something's going to change and you're going to get exploded. And then you'll be in trouble. You'll be down. This is a good one. Control the use of the resources and not which resources you're granted. Just granting resources to people, that's fine, but understand why you're granting them, understand why people are using them and how they're using them. This is my favorite part. I like the sales pitch thinking and critical thought. And so this is kind of a redo of the first page, but the important parts now is by developing your skills for asking questions and critical thought and logic, you start to become relevant. These tools transfer. To enhance your SRDP, maybe you'll get a raise out of it. To make your CV and or resume shinier. It'll make you look better down the road. If you have high levels of critical thinking and logic and thought, you'll be able to augment those other parts that you don't know so well. If you don't know anything about, for example, SSL, because you know how to go out and learn, you can go out and build and foster your SSL knowledge. That transfers across the board in life. And, well, that sounds like philosophical. Sorry for that. Some of the tools SOS offers. I'm not going to read these. I stole these with cut and paste. My mouse is at fault here. I plagiarized, so I gave them a little link to their website you can go to. But intrusion detection and prevention tools, that's PII. Yeah, that's the PII stuff. I think that's the PII. Oh no, that's Snort. That sits on your network, watches traffic. And SOS watches the information from there and will let you know if it sees anything nefarious. Vulnerability assessment, that's one of the tools, services they offer, as well as the web application assessment. You contact SOS, say you have something you want scanned, and they can do either or both. And they're automated. They'll get your reports back. You can process the reports, and then you can submit them again and ask them to rescan and make sure everything's copacetic and A-OK. Two other things. Well, actually, they have three. PII is kind of important. I have a coworker here that lives for PII and scanning. I don't like it. It's intrusive, but I have to do it. So PII is another one of those things on there. Identity finder. Yeah. Security assessment analysis. Essentially, SOS will come in and you can have meetings with them and just kind of talk over what you plan on doing or might do and have some plans, and they give you some ideas. And I got this new one here. It's not on their website. I got it from Chris Ritzko. We were talking a little bit. The unit assessment. Holistic assessment with recommendations to improve the overall unit security posture, which includes continued collaboration and a feasible action plan. That means they're going to help you out. They're going to come back with you can map out your environment. They'll look at it and come back with recommendations, etc. I just learned about it, so I can't really speak about it or how well it is. I imagine it'll be pretty good because all their other tools have really helped us out in the long run, so I think this will help anyone out that wants to. And again, you can go to SOS's website for that. If you want to read it a little bit more about threat modeling, these three links here, hurry up and write them down because I'm going to change this quickly. Ignore that joke. That's a terrible joke right there. That's a little matrix joke there. So are there any questions or comments? We can use this quiet time to either wrap up or ask questions or get answers, or I can show you some of the output from some of the scans or the Qualsys SSL stuff. Everybody wants to go home. Alrighty. Well, I'm going to show you the Qualsys stuff because I think that's it. Okay, yeah. So I'll show you some of those tools that we use. Hopefully, you don't want to see that. You don't want to see. You don't want to see that. Anybody want to see the Hulk? There you go. So, I hope you guys can see this online. This is just an example of the application security audit that we had done for one of our services. I think it's one of our newer services that we were just running. Nice queue headers and stuff. It tells you what was scanned, how long the scans took, server types, threat levels. So we had no high-level threats, one medium, couple lows, one informational, right? And you can just scroll through here and see. It just kind of gives you it looks terrible on the screen. So it'll give you a breakdown of all the services you're running and what kind of issues it'll find. Certificate information. Let's get down to, that's one problem, is it's not point and click. You have to actually scroll. So one of our medium things here is Apache HTTP remote denial of service. It did take us right there. Excellent. Except there's no there we go. And it's a scripting issue, and basically it says you're giving out the version number of your Apache. Oh no, this one doesn't. This says you have an issue. Defect tools circling, yada yada yada. This is fixed in Red Hat. We have Red Hat. This is something you have to do. Is when you get these, you actually have to look and see if it applies to you or not. In our case, even though Red Hat's shipped version of Apache is 2.2 whatever, they actually backport the security fixes into their code. So this was backported and done in our code. So it was handled. And if you scroll through here, you'll see other ones, some hijacking issues that we've cleaned up. since we got the scan run. There's a vulnerability one that's the same kind of format, the Senex. And the other thing I wanted to show you here real quick is the security. Oh, nope, that's not it. It's here somewhere, or else I 86'd it. And these are those ones I was telling you about, those good links. And it's gone. If you bear with me, here we go. It's from SSL Labs. So essentially, it's rescanning Scholarsphere because I lost the page. This will take a minute or so, but the output is useful, and I think everybody will gain a lot from going here and running their own scans here. 46 seconds. Please wait. Any questions online? Whatever you're standing here waiting? No. Oh, it was that boring. Yes. Excellent.
Does scanning like this affect the production server or anything like that? Or?
Well, I know it doesn't in ours, but yes, it could. I mean, this is just checking your SSL connections. So this one is fairly safe. But yeah, I mean, when you do scan your stuff, make sure you scan your QA systems, your staging, your testing systems first. Mitigate those issues, and then push them to another. What we do is we have QA, so we do all our testing there. We scan those boxes, and then we push the code to staging, and then we scan those again. And then whatever staging is, we just mirror those to production. So we're never actually rescanning our production services. It's a philosophical issue. You can, but why risk people's data? I mean, if you have a mirror image, scan the mirror image and go from there. Okay. So I got an A. Yay. I didn't have an A when I first did this. I learned a lot about SSL. I thought I knew enough about SSL to be decent, but I didn't. So 100% certificate because we're using Komodos. And these other ones, you know, score a little bit lower, 85, 90. You can go through and here it tells you about the certificates, the certificate chains, certificate paths, fruit certificates, the protocols that you're supporting. Most people support, Red Hat supports TLS 1.0 and SSL 3. The newer Red Hats are going to support TLS 1.1, 1.2. I'm not sure what, I should say Apaches. And the newer Apaches and OpenSSL support all the way up. And as you get to the TSL 1, 1.1, 1.2, there's more features in there to mitigate all the older SSL and TLS risks. You can see the ciphers that we use. And these are all easily obtainable if you want to learn how to use a command called OpenSSL, or you could use it through here, which is a lot cleaner and easier. Shows you all the different kinds of handshakes different browsers use by default, and it tells you which ones that it defaulted to when it connects. Down here, this is kind of the fun stuff, these protocol details. These are things I don't understand too well myself. I'm still learning. RC, here's session resumption. We don't do that. I'm not sure what ID even means. So when you're here, as you're using these tools, there's still a lot of learning that you have to do. Sounds like I don't know anything about SSLs. I'm standing right here. But this is a really good spot to go. Forward secrecy, and it'll show you, it'll give you information about the different things, what they mean, and why they're important to new web applications, etc. But I just wanted to show you some of the outputs that we get from external sources to secure our systems. With that being said, are there any questions from anybody? Anybody want me to draw pretty graphs on the board? Or did I fail? No, given that it's 4:15 on a Friday, let's go home or back to work. Thank you.